Earlier we looked at exponential functions, and now we're going to look at logarithmic functions, which is going to be the inverse of our exponential function. And here's an example. We have f of x equals log base a of x. And here in this equation, x is going to be here greater than 0, a is greater than 0, and a does not equal to 1. Now let's look at how this logarithmic function is related to our exponential function. And this is going to be a key part right here of understanding our logarithmic function. We have y equals log base a of x if and only if a to the y equals x. Now over here in this exponential form, we know that a is representing the base. Well, in the logarithmic form, this is read log base a, okay? So here again, a is the base. And over here, we know that y clearly is the exponent. So a to the y. So over here, when we take the log base a of a number, we're actually finding the exponent, okay? That's what we're actually finding here. So if we have y equals log base a of x, we're saying a raised to what power, a here, the base, raised to what power is going to be equal to x. So let's look at an example of this. Here we have log base 2 of 16 equals 4. And we want to write this in the exponential form. Well, that means we have base a raised to the exponent equals x. Well, in this problem, log base 2, so 2 is the base. And remember, when we take the log of a number, we're taking log base 2 of 16, the 4 is the exponent. So we're saying 2 to the 4th power equals 16. And we know that's true. 2 to the 4th would be equal to 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So here we have our exponential form. And this is something that's very easy once you get the hang of it, but for some reason can be a little confusing at first. But really make sure that you understand this before you continue. So here we have another example. Log base 4 of 64 equals 3. 4 is the base, okay, and the 3 is the exponent. So 4 cubed is equal to 64. And over here we have log base 5 of 1/25 equals a negative 2. Well, once again, the 5 is the base, the negative 2 is the exponent, and that's equal to the 1/25. All right, now let's look at how can we go the other direction. We have the exponential form, and we want to write this in logarithmic form. Well, once again, the 5 is the base, so that would be log base 5, okay? And we're taking the log, and we know that this is equal to the exponent, so it must be equal to the exponent 2, because when we take the log of a number, it's equal to 2. Well, the number we're taking the log of is the 25. So log base 5 of 25 equals 2. And basically what that says is 5 raised to what power equals 25? Well, it's 5 squared equals 25. So that would be the logarithmic form here. So let's try this one over here. 16 to the 1/2 power equals 4. Well, the base is 16, so that's going to be log base 16 of the number 4 is equal to the exponent 1/2. And then we have one more example. Again here, 3 to the negative 2, the base is 3, so that would simply be log base 3 of the 1/9 equals the exponent negative 2. Okay, now make sure that you really understand how to rewrite these problems from one form to the other. All right, now we want to talk about something called the common logarithmic function, or what we sometimes just simply say the common log. And here, this is where your base is understood to be 10. If you know, before we had different bases up here, but now when we have log base 10, we're just simply going to write log. If there's no number here, it's going to be understood that this is representing a base of 10. So if we have the following examples, log of 100 equals 2, then this is understood to be a 10. Just like when we write the variable x, that's understood to be 1x. Well, down here, this is understood to have a base of 10. So if we write this in exponential form, we know the base is 10, the exponent is 2, and that's going to be equal to 100. So over here, when we have log of 1,000 equals 3, but there's no base here, so we know that's going to be base 10. The exponent is 3, so that's 10 cubed equals 1,000. And then for the last one, we could do the same thing. Once again, the base down here is understood to be a 10. The exponent is 4, so 10 to the 4th equals the 10,000. And that's all that we mean when we have this common logarithm. So then how can we take and write this in logarithmic form? Well, now we have 10 cubed equals 1,000. Well, that means we would write log base 10, okay? So, and I'll write it in here. This is understood, so we don't really need to write it. So it's log base 10 of 1,000 is equal to 3. So we would simply write this as log 1,000 equals 3. And again, over here, 10 to the negative 2 equals 1 over 100. The base is the 10, so that would be the log, understood to be a base 10, of 1 over 100 equals our exponent of negative 2. All right, now we're going to look at, we talked about the natural base e. Well, now we're going to have the natural logarithmic function. And you can see here that, once again, here we have our base e. Okay, the base here is e. And again, because this occurs so much in natural situations, we actually have a formula for this, or a notation rather. Instead of writing log base e, as we do here, we simply write ln. And when you write ln, it's understood to be this log base e. So we just simply write ln of x. And again, this is not any different than what we were doing up here above. It's just that now our base is this e. Now remember, e is just simply approximately a number of 2.7. So here we can do the same thing. How can we take and write this equation in exponential form? Well, we know that because this is ln, we know at the base, this is understood to be a base of e. So that would be e raised to the exponent. Well, remember, when you take the log of some number, you're finding the exponent. So the exponent here is the negative 1.099. And again, the dot, dot, dot just means this decimal continues on forever. So e to the exponent of negative 1.099 is equal to 1/3. Now, with the other example, natural log of 4 equals 1.386. Well, again, this is understood to have a base of e, and the exponent is the 1.386, and that is equal to the 4. And again, what we're saying is e raised to the exponent here of 1.386 is going to be equal to the number 4. All right, and then our last couple examples here is going the other direction. How can we write this equation in logarithmic form? Well, we have e to the second power equals 7.389. So we know the base is e. So that means we would have log base e, but instead of writing this as log base e, we would simply write ln. That means log base e. So it's ln of 7.389 is equal to the exponent of 2. And the next example, we have e to the negative 3. Again, we have a base of e, so that means we would have the ln of our number here, which is 0.0498, and that'll be equal to the exponent negative 3. So the main thing I want you to get from this video is how to write from exponential form to logarithmic and from logarithmic form back to exponential form. And also be aware of what we mean by the common logarithm with a base of 10 and the natural logarithm where we have a base of e. So once again, make sure that you really understand how to write from logarithmic form to exponential form and from exponential form back to logarithmic form. The better that you understand this idea right here, the easier the rest of this chapter will be for you.